Okay. Sorry. Good morning. I think in the last time, I asked the case of the landslide in France, and thank you for your help to provide some very useful information. And I would like to say, because I need to connect to my office, I will let you know what we got in the last time. Okay. So if you can use the Google Earth. Anyone use Google Earth before? Right now, we can download the Google Earth Pro, a standalone software. You can install that in your computer. Okay. In the last time, okay. Okay. So maybe I need to. Much better. Okay, you can find this side is the landslide in showing on the report, and from the picture. Okay, let me check. And actually, the location is not so correct. So maybe I can correct the right coordinate to you. I think the landslide will be in this area. Okay, and so I try to check by the Google Earth. So it is very convenient tool if you can plot a path, just like me, one path. So you can check the profile. Very quickly. Okay, so because the Google Earth already have the digital elevation map. Okay, so when I have I mean the path, I can check the cross area. I mean the profile of the elevation of this slope. So this slope more than 20 meters high. And the width is maybe 75 meters. Okay, so I think the first it is very useful to if you try to recognize the profile in the field. I think the Google Earth will be a good tool if you have nothing. I mean, if you do not have any kind of the map, elevation map, I think the Google Earth will be the first tool you can use. Okay. And the last time I asked you to find the rainfall. So I think this is much useful. So this is the picture in the field. Okay, so I think this is actually the area of the landslide from the street view of the Google map, from the Google map. And I think this is the geological map. Okay, from your help, I can use this from to check the geological map. I think maybe in this. Yeah, this one, right? Okay. Geological map here. Okay, so I think it is very useful. And of course, you help me to find the rainfall. The slope is triggered from the 5th March. So you can find here, before the landslide, this is a lot of rainfall event nearly the city. I don't know how to pronounce this. The Strasbourg. No. Okay. Okay. So you can find the accumulation of the rainfall is very, very big. Okay. Up to the maybe in that time up to the 70 or 80 millimeters. So after the rainfall in this day, the landslide trigger. Okay, so I think there will be a major reason that why the slope fell. Okay, so thank you for your help to identify the cause of the landslide. Okay. So we will continue the slide because I think I need to speed up okay, all the content of this course. So here I would like to continue the issue of the sedimentation in the Simon Reservoir. Okay. So here you can find a picture. In the last time I say we have a big typhoon event in the 2004 Ai typhoon. Okay, so for the calculation from the elevation measurement, we found more than 27 million cubic meter of the sediment deposit in the reservoir. Okay, and for this week, you can find this is the very dirty water. So the water supply suspended at that time more than 17 days. Okay. So you can find this is what we call the density current. Okay, here. Because the density of the sediment is larger than the water. So when there's a movement from the upstream, okay, from the watershed, and the sediment will go through to the bottom of the reservoir. So that's what we call the density current. And then we'll transport to the front. This is the dam side, to the front of the dam side, and trap at that area. So I think right now, more than one third of the volume already occupied by the sediment. 1/3的土壤已经库容已经被埋住了。So I think in Taiwan it is very hard to find a new place, a good place to build a new reservoir or a new dam. It is very difficult because you can understand the geological condition is not so stable in Taiwan. So how do we extend? I mean the life of the reservoir is very, very important. So the original design of this Simon Reservoir is maybe only 50 years or 60 years, but right now it is more than 50 years old. So we try to extend the life of the reservoir. So one issue is that to reduce the sedimentation, I mean the soil from the upstream going to trap to the reservoir. We're trying to reduce that. So based on this, requirement and concern, I developed in my PhD degree to try to find a method to measure the sediment concentration in the field, because just as I said, the previous or typical concentration measurement is from based on the acoustic or the optical, right? But somehow this kind of the method is limited and affected by the soil particle size. Okay, so in my PhD degree, I developed TDR-based method for the suspended sediment concentration measurement. Okay, I would like to say in my PhD degree, I almost used maybe more than 4 years to understand and to develop the technology in the laboratory. Okay, and after the 2008, I get my PhD degree and I started to the postdoctorate. But I found that I still need more than 5 years to apply this method in the field. Okay, so you can see here this flow plate and all the system is developed in that 5 years. And actually, okay, so finally, the method is good for the application in the field for the sediment concentration measurement. Okay, the accuracy or the resolution is about 1,000 ppm. ppm is mean that, for example, if you have 1 liter of the water, 1 ppm, 1,000 ppm means that 1 gram of the sediment inside of the 1 liter water. Okay, so you can find it is very small. Okay, so the accuracy is about 1,000 ppm, and the range is more than 300,000 ppm. I mean that if this is the soil, I can still measurement. Okay, and the most important is the particle site independent. Okay, and for the field, most important is the real-time measurement. All the data can be transmitted immediately to the office. Okay. So in the last time, as I said, this is the front of the reservoir of the cement reservoir. Okay, and this is the water flow. Okay, so I put lot of station. I mean float plate station, and measure the sediment concentration in the different depths. So you can find here, this is the water depth. Okay, and this is the concentration, and this is the time. Okay, so from the upstream to the downstream, you can see here. Just as I say, the density current is transport underneath, okay, of the reservoir. So during the typhoon event, you can find here, this is the great sediment concentration transfer through the reservoir. And finally, you can find here all the sediment trapped in the front of the reservoir. This is a lot of concentration, okay, of the sediment. So, however, we got a sluicing tunnel like this one. Okay, so we open the gate and let the high concentration flow go throughout the dam. Okay, so I think this is the most efficient way. What we call the flushing, okay, sluicing, okay, of the sediment. So you can find from the surface of the water, it is very clean because this is a spillway. Okay, from there's a very clean water here, but because the inlet of this tunnel is the elevation is close to the bottom of the reservoir. So the sediment with a very high concentration sediment will be sluiced out. So this is another typhoon in the 2015. Okay, so you can find still there's a lot of sediment transport from the upstream to the downstream. Here, this is the gate, the main dam side of the cement reservoir. So maybe in this class we can find some time to bring you to the cement reservoir. Okay, and maybe we can see actually the station in the cement reservoir. Okay, and also I would like to introduce the TDR-based transmission line-based sensing technology. One is that the level measurement. So for my research, I also developed some kind of this level measurement to measure what the water level, and also most important, the riverbed interface here. Okay, because we try to understand the scour problem. Okay, because the stability of the bridge depends on the scour. Okay, so here this is the bridge in the southern located in the southern Taiwan, and we attach some of the steel pipe. This is the steel pipe here, and we install some sensor inside of the steel pipe. And also here, this is the measurement from the one rainfall event in that time. Okay, and I would like to say here you can find, I also install some of the steel wire. Okay, for the measurement. Okay, this is the steel wire here. We have pairs of the steel wire. So this steel wire has tried to measure the interface of the riverbed. Okay, so you can find here, this is the steel pipe. But I would like to say it is very tough work in the field because we need to drill a borehole here first. Okay, because we try to put this wire into the borehole. So we need to drill a borehole in the riverbed in the field first. And this is for the interface measurement. Okay, and this one is just I say it is for the sediment concentration. So I put the sensor attached to the wire. I mean combined together, and one is for the interface measurement, and this is attached on the wire, so we can simultaneously measure the sediment concentration of the water flow. Because you can find here, this is the usual time, but during the typhoon event, the water level will much higher. Rise during the typhoon event. So I trying to understand how much of the sediment concentration in the river, okay, and also the scour condition. Okay, so this is I think the very interesting monitoring in the field. Also, it is very tough and very exhausted, but I think it is very interesting after if you already learn that. And I also try to introduce the next is the laser technology. So I think some of you can play the golf. No? No? Or maybe next time you can find some of the golf player take maybe a telescope with laser distance measurement, because they try to understand how longer they will use the different kind of the golf. Okay, so this is the very useful and very typical one for the laser distance measurement. And for the airborne here, or the ground based, right now we have a new technology, what we call the LiDAR, light detection and the they will scan the face. You try to monitoring. So for the airborne, they will scan. So actually, you can get the elevation map of this, and also you can use this is what we call the ground-based LiDAR. So you can also have this for the scan. Okay, maybe next time I will find some very interesting topic. Some research use this LiDAR to find the dinosaurs. I mean the sum of the past to understand how large of the dinosaur. Okay, because they can understand actually the range when the dinosaur works. Okay. And also, this kind of the laser will be implemented to the water for the sediment concentration measurement. Okay, it's just like the light. So we can use the laser to detect the particle size in the water. So this is what we call the LIST, laser institute scattering and transmission metric. Okay. And also this kind of the list can be used for the particle size distribution in the field. So you can find this is the particle size distribution in the micrometers. Okay, I think you can find my lecture in the EE platform. Okay, I already upload all the lecture and in a PDF. So you can download by yourself. And next, I would like to show you a video. Right now, the video is one of the most monitoring technology or tool in the field. So this is what we call the IP camera or the CCTV. It is very common in the street. Okay, and also right now we also have some new product, what we call the time-lapse photogrammetry of photography. Okay, so you can use this with only maybe 2 or 3 battery for almost 1 month or 2 months of the time-lapse monitoring. Okay, we also have one in the maybe next week we can find some time to visit the slope behind our dorm. Okay, and I have already have this time-lapse camera in the field. Also, right now, the drone or the UAV is very useful for the monitoring. Okay, so you can find here, this is the picture. And if you can use the technology of the photogrammetry, you can transfer from the 2D image into the 3D image. This is 2D. But if you have a lot of different kind of the 2D image, you can use this to the 3D. And this is what we call the point cloud. There's a lot of point in this image. This is not a picture. This is the point cloud. And each point have its own coordinate. I mean the X, Y, and the Z. So you can use this to generate some kind of the AutoCAD. It can be implemented into the AutoCAD model or in the BIM model. AutoCAD. Okay. Do you know that we can get the free AutoCAD if you are a student? Okay. So you okay understand because in from I'm a student, the AutoCAD is very expensive. So sometimes I use the crack version before. Okay, but right now I think this is very easy for you to get the free version of the AutoCAD if you are a student. Okay. Yes.
How does it get the color on the 3D one?
I mean, you mean from the 2D picture?
The color. Some at the bottom left, there's some green, and then the rest is a gray and black white.
Oh. Okay. You mean the different color?
Yeah.
I would like to say the point cloud only has the coordinate, I mean the X, Y, and the Z. But you find this image is, the base is the point cloud, but I put the image, I mean the cover, into the, on the front of the point cloud. So you can find this is with a different color, right? Yeah, this is another case. I use the drone, I mean the picture from the drone or UAV. It is in the northern Taiwan. Okay, maybe later I can show you the. So here you can find this is a rock slope, and we have the road here, and we may concern maybe the rock fall from this area. So we use the drone or the UAV to take a picture and generate this kind of the 3D model for the analysis. Okay, maybe I can show you here. Because I don't, this is a very large data, so I put the data in my office. So let me show you here. Where is my, here. This Pix4D is a commercial software to, I mean, generate the 3D model. Okay. Okay, I would like to show you the first. This is the actually the slope in the NCU. Okay, right now I think this is the arrow picture here, and this is our building, right? And I think this is the dome area. So maybe some of you live here, right? And we have a slope just behind the dome, and we have a very sharp slope here. So I use the UAV. So this path and the dot is the location that the drone already have a picture. So let me show you in the next. Okay, so you can find here some of this is the point cloud, a point cloud. Okay, so let me yeah. So here you can find this is a 3D model. We use the several of the picture to combine, and this slope here. We will maybe next we can This is the site we're trying to monitoring. So in this course, in the final project, I think we have 4 groups. Each groups trying to develop your own system and going to the field for the monitoring. Okay, and then this is the one site, and then the other one is let me show you the other one. Oops. What is the problem? Oh, okay. Okay, later I will, because I think this is a different version of problem. Okay, let me show you later. Okay, and let's go back to so later I will show you the original project of this 3D model in the field. Okay, so if you have an interest in, I have a drone UAV, and maybe you can operate by yourself. But right now, I think Taiwan will be much not so friendly for the UAV, because we need the license for operating the UAV. Okay. Okay. Next, I would like to introduce another one is using the sound for the monitoring. Okay. Right now, you can find here. This is what we call the geophone. Okay. This geophone can detect the sound, and I think originally this is the vibration. Okay, so we can use this for some kind. It is debris flow monitoring. Okay, and here you can find this is another issue that extend with the rod penetrate into the ground. So if there is some of the landslide, the rod will have some deformation, so we can have a vibration to the geophone for the monitoring. Okay, so this is a commercial product. You can check the website by yourself. So, and this is the paper in this year, 2020, and then use the geophone for the debris flow monitoring. So you can find, actually right now you may not understand what it is. This is what we call a time frequency analysis, 时频分析哦. So this is the time, and then this is the frequency. So they will recognize which time we have a different kind of the frequency signal. Okay, and also the spectrum. So we can extend the result for understanding the debris flow behavior. Okay. And the next I would like to show you is a GPS. So in this course, finally, in the final project, I will provide all of you of the GPS, each one. So you can use the GPS for monitoring the location and the movement. I mean the displacement in the NCU slope. But however, the traditional GPS, I mean from your car or from your cell phone, it is what we call the single frequency GPS. For someone, we call the L1 spectrum, because this is very cheap, but however the resolution is not so good, because it may be range from the 1 to 5 meters of the resolution. Okay, so for sometime if you drive a car and have a GPS, maybe they will locate it in another block, right? But if we can use right now a new technology, what we call the real-time kinematic position analysis of the GPS, I mean that if we have a base station here, and we also try to monitor it with the rover, so we can use the base of a reference for the difference calculation, because you can find the base station and the rover station receive the same signal from the satellite. So we can have RTK mesh analysis to reduce the sum of the noise from the sky. So we can increase the resolution of the GPS. And of course, right now, in this class, I will give you a Raspberry 3 Pi, Pi 3B version with GPS module. So you can install that by yourself. And I also will give you the source code for the data acquisition. And this is the GPS chip we used before. So based on that, from the RTK calculation, you can get the resolution up to the centimeter. I mean, if you try to analyze the displacement or the movement of the slope, I think right now it can be used based on the GPS. So here I would like to say, if you already understand the most equipment or the transducer based on the different kind of the principle, I already show you that from the mechanical measurement from the to the optical or the laser, in the end the GPS. I try to introduce the most kinds of the transducer for you to understand if you have a project and some kind of the budget, what kind of the instrument will you use for the project. Okay, so I think will be a good database for your understanding. So next, I would like to have a very quick oops. Yes, here I would like to show you the application from the different field in the civil engineering. Maybe some of you is the major in the geotech. Who is in the geotech? Anyone in the geotech? No? In the structural? No? Hydrological? Yeah? Environmental? Okay. No. Okay. So what the topics will you maybe join in the future? Can you share that? What right now? Which topic? Well, is your favorite in the future?
I don't really know. I don't really know.
Okay.
It's general engineering. So
Okay.
yeah, I don't know.
But I think in a master degree, maybe you need to find some topic. No? Okay. You?
Not sure, but I think about energy.
Okay. And you?
Environmental.
Environmental. Okay. How about?
I don't know yet.
I don't know. You don't know yet. Okay. How about you? Okay. Sure. Okay. So I think here I will show you some application from the different kind of the field for the because I'm a geotechnical guy. So the first I would like to show you the geotech instrument at all. So you can find here from this slide, this is the most equipment or the transducer or sensor we use for the measurement in the geotech. Okay. So I would like to use this issue, but I think some of maybe also the environmental issue for the measurement at all. And the first one I would like to show you is the landslide problem. Here, from 1997, how old are you in that time? 1997. Zero. Okay. In that time, we have a big problem in the Taipei County because you can find this is a community in the mountain area. And here, this is the deep slope landslide during the typhoon. And 28 deaths in that time. And this is the second very famous case in the 2010. It is the landslide in the highway. This is our highway. Okay. So in that time, 4 deaths happened. So you cannot imagine when you drive your car on the highway, but suddenly there's a landslide. Wow. You don't have any chance to escape, and you're already buried from this landslide. Okay, I would like to say in the previous slide, I already show you what kind, the most kinds of the instrument. But right now, I would like to show you the potential failure mode beginning from the landslide. So here, this is the most typical case of the landslide from the flow. Okay, so the debris flow like this one, the toppling, because this is the you can find the strike and the dip is inverse with the slope, and also this is lump. This is what we call the curve, the sliding curve, and this is a slide with the layer parallel to the slope, and the creep. Okay, very slow movement, and finally rock fall. Rock fall. So if you are an engineer, if you have a case, try to monitoring for this kind, because in Taiwan we have a lot of the roads next to the mountain, rock slope. So we have a lot of rock fall problems. So what can you do? What kind of the target can you measurement for the early warning? Okay, you need to ask yourself, because I only have a limited project. So what kind of the measurement, what kind of the transducer can we use? Where can I install the instrument in the field for the better monitoring? Because I try to warn the passenger. Okay. So here, this is some picture I trying to show you from, this is the debris floor. Okay, this is the debris floor. And this is a toppling. Okay, toppling. And with the toppling and also this is what we call the wedge value, because we have a different kind of the layer. So if this is the, I mean, have cross, so we have a wedge value of this. So you can find this wedge value because we have two the case from the 2010 in the freeway of the northern Taiwan. And this is the deep slope. Okay, deep slope. And this is from just I show you in the 1998. Okay, and this one is the 1999. 1999. The GG earthquake. Okay, it's 21 years ago. Okay, right? Yes. Yeah. So for this area, this is a very big area. For this, maybe I think maybe more than the 500 meter to 600 meters wide. So this is a very large slope landslide. So here you can find this is a deposit of the landslide. So here we already show in the very beginning of this class. This is what we call the landslide dam. Okay, and block the river. So we have a lake from the landslide dam. Okay, and also this is the Lushan case I already show you, and because this is a very big Peruvian slope. So the deposit of the landslide, the previous landslide, have a very good, very large thickness. So during the rainfall event, there were some have a creep. I mean, a very slow movement in this area. And this is the picture of the rockfall. Yeah, so large, and also for this kind of the rockfall. And here I would like to show you some video from the rock slope. You can find this is almost vertical slope in the field. So maybe you can find this is a very big crack here. Can you see that? So if you are an engineer, how can we find the warning of this kind of the rockfall or the landslide before it is real happen? Okay, this is a real case in the Taiwan. Okay, so I would like to say for the landslide monitoring in right now in the Taiwan, the first we try to understand where is the sliding surface because it's much critical for the next issue. And somehow Also, it is critical, but it is most difficult to obtain from the field. So you can find for the landslide here. This is the landslide. Okay, we have a lot of sensor to monitoring. I think right now we can. I will show you piece by piece. Okay, so the first one will be the rain gauge. Because in Taiwan, I think the rainfall is the most, reason for the landslide. Okay, the other one is the earthquake. But you already know that the earthquake is, right now it is impossible to for the early warning because you never know that when will the earthquake happen. So, but the rainfall can be predicted because right now we have a forecasting of the rainfall and also we have a radar to monitoring the rainfall area. So the rain gauge will be a real target. So here you can find, this is the typical rain gauge in the field. And this is the inside of the rain gauge. So the rain gauge right now, we use the tipping bucket. You can find here. This is the balance of the tipping bucket. So for each tip bucket, maybe 0.5 or 0.25 millimeters of the rainfall. So for this kind of the measurement, what is the result of the signal? It's the number of the tipping bucket. Because if you have once of the tipping bucket, they will show you like this one. And the second one, third one, fourth, fifth. Okay, if this is in 1 hour, so each one may be 0.5 millimeters. So I get maybe 5 count of the tipping bucket. So what is the accumulation, the summation of the rainfall is 0.5 millimeters times 5. So I got 2.5 millimeters rainfall, accumulation rainfall in 1 hour. Okay, so we can use the count for this kind of the rain gauge measurement. I think this is a very easy idea, but very useful for the rainfall measurement. Okay. And the second one I would like to show you is the piezometer for the underground water measurement. Okay, so you can use maybe the traditional one of the strain gauge, right? And we can use the what kind of the sensor? Vibrating wire. Do you know what is that? Vibrating wire. If you already forgot, please find the vibrating wire sensor in the previous lecture. Okay, so this kind of vibrating wire type, or the MEMS type, MEMS, micro electrical mechanical system. Okay, so we can use this for the water pressure measurement. Okay, and we already show that if this is the FS, what is the resolution? 0.01 to 0.1% of the FS. So you need to understand the FS. FS is the full scale, right? The full scale is 300 meters for this case, and the resolution is 0.01%. So you can calculate actually the resolution of the water level by yourself. But I would like to say it is the trade-off. I mean, if you try to have a longer range of the measurement, but you need to sacrifice the resolution. Okay, if you try to keep the resolution, okay, fine, you can find some equipment, but it is very, very expensive. Okay, so you need to think about your budget and actually how much of the resolution actually you need to use. Okay, for this case, I think for the 300-meter range, maybe 5 centimeters of the resolution is good enough. Okay, but if you only have a 10 meter of the measurement, range measurement, I think maybe 5 millimeter to the 10 millimeter resolution, it will be used for the measurement. Okay, so this is the case practical implement of the piezometer in the field, because if you think that I can put the piezometer directly into the borehole and measure the water level, no, this is not so easy. Okay, you need to have a grout with the sand. Okay, so this is what we call the open type. I mean, only one transducer of the piezometer for the water level measurement in single borehole. This is open type. But however, for maybe environmental issue, you need to understand maybe there's aquifer. I mean, there's a confined pressure underground in a different layer. So if you try to monitor the pressure, water pressure in a different aquifer, I mean confined, maybe you need to install more than the 2 or 3 sensors in a single borehole. Just as I said before, the drill borehole is the most expensive in your project. So if I can use the single borehole for the multiple measurement, that will better. Okay, so you can see here, one for the measurement, the other one for the measurement. This is the sand, what we call the aquifer. Okay, I mean there's a water flow here. There's also the water flow of the aquifer here. But however, because this is the borehole, I mean you already penetrate 2 aquifer. So actually we need to seal. So here you can find, this is the seal with the bentonite. Bentonite is, how can I say, it is a soil, can be swelling very, very large if you have a high water content. So this kind of the bentonite can be sealed between the layer of this aquifer. So you can find this is the implementation of the piezometer using different using the multiple sensors in a single borehole. But however, in the last time, I already said that because the borehole only maybe 7 centimeters to 10 centimeters, okay? But if you try to put the multiple sensor inside, means that you need several transmission line cable. But you can find, if I have 3 or 4 sensors in a single borehole and I try to seal, for example, here, if I have another one and I try to seal. So for the first layer of the seal layer, you can find it is very, very hard to seal at all because you do have so much cable. Okay, and the spacing between the cable is very, very small. So maybe we can have a leakage. between this space. So how can we do? In the last time we say we can use the FBG, fiber black grating, because you can use a single optical fiber to connect several FBG for the measurement. So only one transmission line we need to use. But however, just as I said, the FBG, the main system is still expensive. How much? 30,000 US dollars now for the main system. However, right now, based on the advance of the electronics, we can use what we call the RS485 technology for the data acquisition and the transmission using only one single cable. Okay. So here I have a very quick homework for you. Okay. Maybe in the last time you already know that what is the RS232, and here this is the RS485. Okay. I would like to say this is the different kind of the transmission protocol in the industrial, but it is very easy and very useful for this maybe 20 or 30 years. So I would like to ask you, all of you, in the groups, okay, in the groups. So please find some report or reference and show me that what is the difference and what is the benefit from the RS232 and the RS485. Right now, you already see one benefit. Using the RS485, you can connect multiple sensors only using one single line. Okay, this is the most benefit from the RS485. Okay, so please help me to tell from the difference between the RS232 and the RS485. And this is the commercial product. I cooperate with the company to develop this kind of the piezometer, multiple piezometer in a single one transmission line. Okay, so I think this is very useful if you try to put maybe more than 3 or 4 or 5 piezometer in a single borehole. This is will be good because compared to the FBG, fiber optical sensors, this is much cheaper. Okay, so maybe we may have a 5 to 10 minutes break. So during that time, I will find the 3D model for you. Okay.